Hello students. So till now we have seen what do you mean by Markov model and hidden Markov model. We have also seen how numericals can be solved on both Markov as well as hidden Markov model. Today we are going to see how we can apply Bayes rule to hidden Markov model. So if you see over here, I've considered a state transition diagram where we are going to apply Bayes rule to hidden Markov model. As you can see here, we have been given the state transition diagram. We have got two states, rainy and sunny. And there are four observances or observations. H stands for happy and G stands for grumpy. So each of these two states have got two observances respectively. As we all know, in hidden Markov model, the states are hidden. Only from the observances we have to find out the probability. Initial probabilities are given. Probability for rain 0 is 1 by 2 or 0.5, and probability for S0, that is sunny at day 0, is 1 by 2 or 0.5. The ones that you can see over here are your transition probabilities, and these are nothing but your emission probabilities. Okay, so now coming to the question. Suppose that it is observed that a person is happy on day 1, which is denoted by H1. This is our assumption. So we are assuming that a person is happy on day 1. So the question is, what is the posterior probability for which raining on day 1, or what is the posterior probability for it to be sunny on day 1? So a person is happy on day 1. On the basis of that, you have to find out the posterior probability for it to be raining on day 1, as well as the posterior probability for it to be sunny on day 1. So first, what we are going to do, probability. Yes, first we always write down to find. So we have to find out the probability for it to be raining on day 1, that is why R1. Yes, given that a person is happy on day 1. Now here we are applying the Bayes rule, which is nothing but probability to be happy on day 1, given that it is raining on day 1, multiplied with probability of raining on day 1 divided by probability of a person to be happy on day 1. Now each of these values have to be found out separately. So first let us see how do we calculate probability of it to be raining on day 1. So this is nothing but your Markov model. Alright. So if you see over here, probability for it to be raining on day 1 is nothing but your probability that we have to find, given that we consider the previous probability. So it is R0 into probability of it to be raining on day 0. Now because we have got happy in both rainy as well as in sunny, we will be finding it for both, that is S0 as well as R0. Clear? So probability of rain 1 given that R0 plus probability of rain 1 given that S0. Now these values are nothing but obtained from your transition diagram. So what is this? R1 to R0 is nothing but we consider 0.6. Alright, because explicitly the values of R1 and R0 are not given. So state transition into probability of R0 is nothing but the initial probability which is given in the question, 1 by 2, plus probability of R1 S0. Now this we can find out. So what is that R and S? So what is this R1? That means we have to find. So we will be looking the arrow towards R, which is nothing but 0.2 into probability of S0 is 0.5, which is again given in the question. On multiplying you get probability of it to be raining on day 1 to be 0.4. Alright, so this value is obtained, which is 0.4. Now probability for a person to be happy on day 1 given that it is raining on day 1, if you look over here, we have to find out H given that it is raining, so it is nothing but 0.4 from your emission probability. So we have obtained this as 0.4 and this as 0.4. Now we have to find out probability of H1. So again we are going to apply the Markov model. Alright. So what will happen in that case? It is nothing but probability of a person to be happy on H1. This we have to find given that it rains on day 1 multiplied with the probability of it raining on day 1. Now happy is present in both cases. That is why we have to consider S1 also. So probability of H1 given that it rains on day 1 into probability of R1 plus probability of H1 given that it is sunny on day 1 into probability of your S1. Now we know this value H1 R1 which is nothing but 0.4. Probability of R1 is also calculated which is nothing but 0.4. H1 S1 can be found out from the state transition diagram which is nothing but 0.9. Now we are stuck how to find out probability of S1. Now probability of S1 can be found out in two methods. I'll show you both the methods. Since we know that probability is always lying between 0 to 1, okay, so here in this case what it is going to happen, that we know a person is going to be happy on day 1. So that is why, yes, probability of S1 plus probability of R1 is equal to your 1. So probability of S1 is nothing but 1 minus probability of your R1. And R1 is already known, which is 0.4. So 1 minus 0.4 is 0.6. This is the first method. Our second method of finding probability of your S1 goes in a similar manner like that of your probability of your R1. So if you see, you can also find out by this particular pattern. Probability of your S1 is nothing but probability of your S1 given that it rained on day 0 into probability of rain 0 as written over here plus probability of your S1 given that it was sunny on day 0 into probability of S0. When you are substituting these values, it is nothing but from the state transition diagram when you get it is 0.4 multiplied with your 0.5 plus 0.8 multiplied with your 0.5. 5. So when you solve this, you get the answer to be once again as 0.6. So you can find out P of S1 in both the ways. Is it clear? So we have found out all the three components P of H1 given that R1, P of R1 and P of H1. So while substituting this, you will get the value. So see over here, once you substitute, you get the value as 0.229. So what is it? Probability for a person to be happy, all right, on day 1, given that it is raining, is 0.229. And look at the actual graph if you look over here. Okay, so what is it? We had to find out the probability for it to be raining on day 1. Okay, so what is it? Here, if I'm considering initially for a person to be happy when it is raining was 0.4, and now what has happened? It has reduced to 0.229. So the probability has decreased. Clear? Thank you.